Good morning. Good morning. Yes, there we go. I got at least one. Hi. It's great to be here at Build Stuff. What a fantastic set. This is awesome. Yeah, I feel like a rock star or Eddie Izzard at the O2 or something like that. It's great. I'm Mark Rendle, and I'm going to do a talk called Futurology for Developers. I'm calling this the pre-lunch keynote. Because it makes me feel good about myself. But no, the idea for this talk, this is my 30th year as a professional software developer. I started in 1989. And I was just looking back over those 30 years and thinking about the state of technology when I started. And then I thought, what's it going to be like in another 30 years' time? And that's how I had the idea for this talk. And so I'd like to take a look back at the stuff that I started working on back in 1989 and how that compares to now, and then think about what might happen over the next 10, 20, 30 years and the things that we should be ready for as developers and how we might look to get ready for those. So my first job, when I started, we had 8 developers writing C code on SCO Xenix, which was a Unix derivative containing Microsoft code. I remember that because it said it in the boot up sequence. Contains proprietary Microsoft code. And this was a Tandon 286, and it had 2 megabytes of RAM and a 150 megabyte hard disk. 8 of us would code on this up until lunchtime, and then we would start the build. And then we would go for lunch, and then we would come back for lunch, and then we would have a table tennis tournament. And that lasted about 2 hours, and then the build would have finished. And that XKCD comic about compiling, that was real. And if you broke the build, you were the one who had to stay late to make sure it was all working again the next day. And if nobody broke the build, then the person who lost the table tennis tournament had to stay late and make sure that everything was set up for the next day. So that was completely fair. I got very good at table tennis. This was the Intel 8286 processor, and this thing ran at 8 megahertz. Megahertz, not gigahertz, 8 megahertz. One core, 190,000 transistors, and they were 1.5 micrometers across. It was 16-bit. It could address up to 16 megabytes of RAM, but 16 megabytes of RAM in 1989 would have cost you tens of thousands of euros. Not euros, obviously. The euro didn't exist in 1989. It would have cost you tens of thousands of pounds, or whatever your equivalent currency was. It did 1.6 million instructions per second. Those were integer instructions. It didn't do floating point operations. If you wanted floating point operations, you had to buy the very expensive 8287 coprocessor, which was a floating point optimizer. And back in 1965, Moore's law was coined. The number of transistors doubles about every 2 years. And Intel have done their best to keep that true ever since. And they're just about failing now. A current processor, I'm going to use the Apple A12X as an example. It's not the latest Apple processor, that's the 13. But the 12X, which is what's in the iPad Pro current generation, runs at 2.5 gigahertz. It has 8 cores, 10 billion transistors, and that's on a 7 nanometer process. Lord knows how many millions of instructions, but it does 5 teraflops using its advanced neural processing unit. This is the AMD Threadripper. They've announced that in January next year, the Threadripper 3rd generation 3990X will come out. 64 cores, hyperthreading, so 128 logical processors, and that's going to have something like 50 billion transistors in it. And it's a mixture of 7 nanometer and 14 nanometer process node chips inside it. And it's difficult to, because 1.5 micrometers is already microscopic. You can't see that with the naked eye. And so imagining something that you can't see with the naked eye being shrunk down to the size of something else you can't see with the naked eye is very difficult. So I've prepared this simple visualization. If this picture of a transistor here was 1.5 micrometers, then shrinking that to 7 nanometers would look like this. Yeah. I actually worked this out very carefully. It is still there. There's 1 pixel. I sized the one on the left so that the one on the right would be 1 pixel. That is the difference between 1.5 micrometers and 7 nanometers. That's how much smaller transistors have got since 1989. A 2 megabyte SIM looked like this in 1989, ran at 22 megahertz, had 8-bit data width, and it could do about 180 megabits a second. This is a 32 gigabyte laptop DIMM, which does 21.3 gigabits per second data transfer and runs a lot faster. This was the 150 megabyte hard disk. This was a 5.25 inch full height SCSI disk, and for 150 megabytes, it was about £2,000. 5.25. Some people in the room, my generation, Gen X, represent both of you. Thank you. I'm surrounded by millennials. Probably Gen Z at this point as well. It's just got really scary. But yes, if you remember 5.25 inch floppy disks, then this was the size of a 5.25 inch floppy disk drive, but about 4 times the height. By comparison, it was about that big compared to a London bus. Okay, compared to a little toy London bus, that is actually about right. Probably a better way to visualize this. So Samsung now have a 4 terabyte micro SD card that they've created. And if you shrink that down, that's about the equivalent size for those things. 150 megabytes, 4 terabytes, and it fits. You can lose it. You can lose 4 terabytes of data. You can vacuum up 4 terabytes of data accidentally and go, oh, what's that rattling around the Hoover? I've washed terabytes of data and then put it through the tumble dryer, and it's come and it's still worked. I mean, you couldn't do that with a 5.25 inch full height SCSI drive. Washing machine wouldn't survive anyway. This was a Wyse 50 terminal. This was what I had on my desk because I was new. The experienced senior developers had a Wyse 60 terminal, which had exactly the same capabilities. It was just grey instead of beige. But yes, 80 by 24 characters, 2 colors. It was either green and black or orange and black, or we actually got the Wyse 120s after a while, and those were black and white. It was really high tech. There was no Ethernet or anything in those days. These things were connected to the Tandon 286 using RS-232 cables, and one of my jobs was to make those RS-232 cables, and I still have solder scars under my fingernails from where I used to do that. So yes, hands up anybody who started coding in the last 10 years who has scars to prove it. No. There were laptops in 1989. This was the 286 laptop, which had a 286 CPU, 640K of RAM, because we were still in the days when Bill Gates was saying, why would you need more than that? 40 megabyte hard disk, ran for 3 hours on the battery, cost £6,000 and weighed 6.4 kilos. And yeah, you did not get many people turning up to conferences and sitting there coding while somebody was talking with one of these on their lap. Just Rob. This is a modern laptop. If anyone watches this and thinks, my God, that was so good, I'd like to buy him something nice to say thank you, that's what I want. It's the Lenovo ThinkPad X1 Extreme, 6-core processor, 4K touchscreen, 64 gigs of, it's bonkers, weighs less than 2 kilos and costs roughly less than half of what that compact used to cost. This was our printer, and this was a dot matrix printer. back in those days, so now we do code review and we do it on GitHub or GitLab or whatever we're using for source control. Someone does a check-in, opens a pull request, and everybody goes in and says, you suck at programming, let me do it. In those days, if we wanted to do a code review session, we would print out the code and then go into the conference room and put the printouts on the table and mark it up with a red pen. And the noise that this thing made is not coming through the speakers. No, never mind. It made a lot of noise, just take it from me. And then there were a lot of things that we take for granted now that just didn't exist in 1989. So the internet, that wasn't there. If I wanted to find an answer to a question, I had to ask people sat in the same office. If I wanted to look up documentation, I had to open the ring binder that contained the documentation. And if I wanted porn, I had to go to the newsagents. There was no Wi-Fi, there was no networking, there was very little anything at all. There was definitely no cloud. If you wanted a server, you had to fill out a purchase request, and then that had to go off and be dealt with by finance, and then go off, and they would eventually deliver a server, and you'd install an operating system on it. And devices, no, there were no mobile devices of any kind at all. The first mobile device was the Apple Message Pad, which popped up in 1993. Back when Apple used to innovate, instead of just watching what other people were doing, waiting a couple of years and then doing it properly. But it was terrible. It weighed more than half a kilo, and it had 4 megabytes of memory, and it's supposed to do handwriting recognition, but you could write something on it and then take a slurp of coffee, and it might possibly have caught up and appeared on the screen. Of course, now we have the Apple iPhone XS. We've got the iPhone 11 now, and this is, there's more computing power in that than I think existed on the planet before 1980, which is, and what do we use it for? Twitter. God, we're doomed. So we made a lot of progress. Things have got faster, things have got smaller, things have got lighter, things have got preciser. Maybe not a word, I don't know. Things have got powerfuler. Okay, that's definitely not a word. And things have got connecteder. I'm just making these up at this point. But feel free to start using them, and then I can go, I coined that. So this is my new hobby, extrapolation. Looking at that kind of progress that we've made over the last 30 years, and then looking at what we've got now and trying to apply the same process to that, the same kind of evolution. What's that going to look like? So if we extend Moore's law out to 2049, then we would have processors with 328 trillion transistors on them. Except that can't actually happen, because transistors, CPU dies, the individual core dies, have a maximum size that is constrained by the speed of light. And we can't make them any bigger than that, because the speed of light is a constant, despite what YouTube might say. And we can't make transistors much smaller. So TSMC and Samsung have both got 5 nanometer ready to go next year. Samsung say they're going to be ready to go in 2022 with 3 nanometer. It has been suggested that 1.4 nanometer or 14 angstroms might be possible. But we really can't get much smaller than that. And the reason we can't get much smaller than that is that a silicon atom is 0.1 of a nanometer across. And you need more than one silicon atom to make a transistor. And so we are really running up against the limits of how small we can make these things. And people are looking at different materials and different technologies for processors. So we're currently using silicon germanium as a mix to create these 7 nanometer, 5 nanometer, 3 nanometer. And that's let us go a lot smaller than we thought we were going to be able to go. People are suggesting that it might be possible to make processors out of graphene and carbon nanotubes. But at the moment, we can't make anything out of graphene and carbon nanotubes because we can't actually manufacture it at scale. Photonic processors, we actually have photonic processors that work by bouncing light around, but they're the size of like a microwave. oven, so they're not putting one of those in your phone anytime soon. Organic processors. So we have the most powerful computers imaginable in our heads. We have no idea how it works. We just don't know. How what's in there is picking up all the photons, bouncing off all the people in this room and turning them into stuff, and then searching against some kind of memory store so that some of these faces I'm seeing I recognize, and I go, I know that guy, I met him at Build Stuff a couple of years ago. We don't know how that works. But if we can figure out how it works and we can recreate it in a laboratory, then we might be able to build brains that work the way our brains work, which could be interesting. And then we've got quantum computing. Has anyone tried quantum computing on any of the things that you can play with so far? Just me. Yeah, as far as I can tell with quantum computing, you put in your variables, your values, and then you run them through an H gate, and then random. I don't know how it helps really, but at some point somebody is going to give a talk on quantum computing at a conference, and they're going to say that small combination of words, and I'm going to go, ah. What I do know about quantum computing is that a 64-bit register can hold 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709 million, 551,616 different values all at the same time. So if you've got a program that wants to work out which one of those 18.4 quintillion values is the right one, you just load them all into the computer at the same time, and then you run the program, and the one that's right becomes the output. And I've been reading about this. They say that the way this works is it runs the same operation across 18.4 trillion parallel universes, and then they all share the correct result from the one that found it. Each one gets a different... Yeah, that's distributed systems at scale, Randy. Yeah, we think there's a bug, but it's not in our universe. Ultimate slidey back. Yeah, no, definitely it's universe 15B. So, we're getting smaller, we're getting faster, we're getting cheaper, and computers are now everywhere. I wanted to see what computers I had in my house, and so I went onto my Wi-Fi router and I thought, what's connected to my Wi-Fi router? 8 computers, 8 phones and tablets, 2 Xboxes, 1 PlayStation, 2 Nintendo Switches. My kids are the luckiest kids in England, I tell you. They're going, Dad, can we... Oh, you've already bought it. The TV, obviously the TV is on the Wi-Fi, 3 Sky Q boxes, 2 Fire TVs, actually that's 3 Fire TVs now, 2 wristwatches, 6 Echoes, 3 books, all the light bulbs are sort of on the Wi-Fi, they're Philips Hue and whatever else, the doorbell's on there, the washing machine's on there, so we get a notification that pops up on the television that tells you the washing's finished. The printer, the camera, of those, these things would not count as proper computers in the sense of a box with a CPU and an external display and everything else. And these things would not really count. If you'd said to me 20 years ago that these would be computing devices, I would have said, what? Why would your book be connected to the Wi-Fi? It was unimaginable that that would happen. And things are getting smaller. And as developers, we have to be able to write code for these things that are getting smaller. And the people who are making the tools are starting to recognize this. Most modern application development environments will now let you target ARM. .NET Core 3 runs on ARM, Java runs on ARM, Rust, Go, C and C++, obviously you can build for ARM. And if you want to sort of muck about with this kind of thing at the moment, then it's very cheap to get some devices and start running things. A Raspberry Pi 4B, which costs about 35 to 55 euros, depending on how much RAM you want on it, that will run quite a lot of stuff. you can put 5 of those things together and it's a Kubernetes cluster. And you can run your entire house on that. You can run that as a media server. You can put RetroPie on it and use it as an arcade machine that will run the games that you used to play in amusement arcades in the 1990s, where you were just going, oh, wouldn't this be great if I could have this in my house? And then you get a RetroPie and you put it on there and you build an arcade cabinet around it and you open it up and you go, yay, God, these graphics are useless. There are alternatives as well. There's the Asus Tinkerboard, which is a little bit smaller and more powerful than that. You've got the Raspberry Pi Zero. This costs €10 and it's tiny and you can run it off a battery for a month. And you can do all sorts of things with that. And then at the other end, the higher end, you've got the NVIDIA Jetson Nano. This is a board designed for doing AI, machine learning, deep learning, image recognition, voice recognition, actually at the edge rather than shipping things up to the cloud and then doing it. Interestingly, buying one of these in bulk to put into manufacturing, they're quite expensive, but you can pick up a developer board for about €100. And it's worth getting one because it'll run sort of tensor operations or ML.NET operations really amazingly fast. There's lots of others as well. There's also Arduino, which is different. You can't run an operating system on Arduino. You just write code, and then it's like unikernel sort of thing, basically. You load code onto it, and it runs on a device. If anybody... sorry, yes. I added this in because somebody at the last talk pointed this out to me. The thing about ARM CPUs, as opposed to Intel CPUs, is obviously ARM CPUs use a lot less power. And we know that's important for phones and Internet of Things devices and so forth. But I wonder how many people in this room are running workloads in the cloud on like an M2 large or an Azure DS2, DS4 or something, that actually would quite happily run on a Raspberry Pi or an ARM server of some kind and use something like 5% of the power to actually run that same workload. How much useless carbon are we generating? They're saying by 2030, so in 10 years' time, 20% of the global energy use will be ICT. It'll be the stuff that we're doing that's using 20% of the energy that the world consumes. So 20% of the carbon footprint. If we switch to low-powered processors and ARM devices and so forth, then we might be able to bring that down a bit. Hands up who's planning on living past 2050. My God, some of you are negative. But yeah, if you are, it might want to be something that you want to think about. There are actually places where you can already get ARM hosting in the cloud. Some of them will just give you a Raspberry Pi. They'll plug in a Raspberry Pi with an SSD, and you can run things on it. And some of them have created their own little ARM nodes. Scaleway, Mythic Beasts Packet. AWS are doing A1 instances. They use a lot less power, and if you can check and see if your application will run on those, and it does, then why not do that? So, if you want to get started with the whole ARM stuff, there's .NET Core. Core RT will do native builds. .NET 5 will probably do ahead of time native builds for ARM CPUs. There's a great project at jsandler18.github.io where he builds an OS for Raspberry Pi. Does anyone know Alexander Mutel? I think he works for Unity. He's on Twitter at XOOFX. He has done his own C# version of the build an OS for Raspberry Pi, and he's now building a reduced version of the C# language to support that. We've got system.device.gpio, so you can activate the Raspberry Pi's pins from .NET Core 3, and there's lots of other resources there as well. There's a website for this talk, by the way, where the URL will be at the end, so don't worry too much about these links, because they're all on the website. Who's got kids at home and would like to get them into coding? So Microsoft run a brilliant thing called MakeCode, and it's a block-based programming language or a JavaScript language, and you can actually create a block-based game and then hit a button and it converts it to JavaScript, and then you can edit the JavaScript. And the brilliant thing about MakeCode Arcade is there are lots of little devices like the BrainPad Arcade, or Adafruit do the PyGamer and the PyBadge, and KittenBot do the Meowbit, which is lovely. It's like a tiny little Nintendo Game Boy. And you can just plug this into your computer with a USB cable, and MakeCode Arcade will download a file and you drag it onto the storage device for this Meowbit or whatever, and then unplug it, attach it to a battery, and your kid can take it off to school and go, look, I made this game on this tiny little thing. So yeah, I've got the BrainPad Arcade for my son, who's 8, and he loves it because he's, at his age, there's not really that much difference between what he's done with MakeCode Arcade running on the BrainPad and Super Mario Maker 2 on the Nintendo Switch. Okay, so that's things getting smaller and lower powered, and that's good. There was stuff in 1989 that was primitive technology, and I'm thinking things like the printer and the laptop. Those were the primitive technology in 1989. And we've got some stuff that is basically primitive technology right now. Obviously, compared to those things, it's like science fiction, but let's talk about user interface. So at the moment, a user interface is, you've either got a flat rectangle that you're dragging things around on, or you've got a keyboard and a screen, and somewhere there is some computing power between those two things. And that's been the way it is since the 1960s, since the first VDUs were invented. Before that, obviously, it was a typewriter or a teletype. And now we're actually starting to see mainstream virtual reality. I remember they tried virtual reality in the 1990s, and there were these huge machines that they put into arcades. And it's kind of like, it's the future! And we all paid our £5 coins into the future when we put the future on our head, and then 5 seconds later we took the future off because it was making us feel sick. But now you can spend a couple of £100 and you can put the future on your head, and you can keep it on there until you start sweating too much, basically. The future needs air conditioning, in my opinion. But this is sort of where we want to get to, where the entire world has gone to hell because of climate change, but nobody cares because we're all spending all our time in a virtual environment, in a van. Because on the inside, it'll look like this, and we'll have robot butlers and weird things, and we'll be able to make ourselves look like whatever we want to look like. This is current virtual reality kit, so that's the HTC Vive at the top and the Oculus Rift at the bottom. These are the promotional shots. Obviously, what is not pictured here is the many, many, many wires that you need to connect so that once you actually get up and start moving around, you will throttle yourself within about 3 minutes. And also, obviously, the incredibly powerful computer that you need to actually power that headset as well. That'll set you back about £2,000. And then somehow, Oculus came out with the Quest, which costs £399, probably €399, probably $399, probably 499 Australian dollars. That was a Sydney joke. And that's it. There are no wires. There is no anything. It's got a 2-year-old, almost a 3-year-old phone CPU inside it. And it's great. It's got high resolution. It's got a really nice screen on the inside. And you just put it on and turn it on, and you're into virtual reality. And it's got this fantastic game on it, which I love. Do we have volume on this?
Let me show you another way to a better land.
Who's played Beat Saber? Seriously, if you haven't played Beat Saber, it is worth spending €400 on a virtual reality headset just to play Beat Saber. I swear, I got the thing. I've got other games. There's a brilliant Star Wars series on it called Vader Immortal, and there's a few other things on there as well. But Beat Saber is my daily exercise routine. I swear to God, I actually put on like a sports t-shirt and shorts to play Beat Saber, because if you do it like this, then you can get through about one Imagine Dragons song and you are melting. But it is completely fantastic. And this is on something with no wires and no anything. It's just basically a phone strapped to your face. And it's not even particularly heavy. That's what we've got now. Of course, there is this fun thing where once you put that headset on, you're completely oblivious to the world around you. And so your kids are coming up and going, ha-ha, poke you in the ribs. And you have no idea. And the deeper you are into a game, the closer that comes to giving you a heart attack. And so we have another technology, augmented reality, or mixed reality as Microsoft call it, where we have transparent lenses and then it injects things, it displays things on those lenses. And where they're not displaying something, you can see straight through. But where they are, you can still see through it. But there is stuff, and it looks like it's there. I think someone out there has got a first-generation HoloLens on the expo floor. The second-generation one went on sale literally this week. This is a phenomenally powerful piece of kit. It's got custom processors in it. The first one had a very small field of view, so it filled in about this. You can see for yourself. The new one has come out to about here, so if you sort of hold your hands out, yeah. It still cuts off after that, and we still want it to get to 180-degree field of view just to really fill things in and everything, but it is very interesting technology. HoloLens 2 is £3,500, or for some reason they will give you one with a $100 a month Microsoft Dynamics subscription. Because obviously that's what you want augmented reality for, is CRM and running SAP. Yeah. But yeah, this is very enterprise and industry focused. This is the Magic Leap, which has got an undisclosed NVIDIA CPU and GPU, probably the X1, and works on a similar basis. It's got a similar field of view to HoloLens 1. This is a developer kit. This is not designed for mainstream use. But despite that, it has already got quite a lot of applications on it, including this one, which is called Cheddar.
Two exciting emerging tech companies announced a new partnership today, which will see the Cheddar network available on Magic Leap devices all across the world, and even in your home.
The markets right now, they had been able to rally into positive territory. We've since moved off those
And we're starting.
So yeah, that's Magic Leap. You can actually get that if you've got a Magic Leap headset, which you can get a friend in the United States to buy for you and ship over to you, then you can download that and have that now. And you too could wander around your house just making screens appear wherever you wanted with CNN and Bloomberg, because despite being a hipster, apparently you're just watching CNN and Bloomberg. But you can get that now, and that's a real thing. And, you know, I mean, okay, fine, yeah. He looks like an idiot, and you're not going to go out wearing those. But this is where I come back to the laptop from 1989 and the Apple Message Pad as an example. So it took from 1993 to 2006, took 13 years to go from the Message Pad, which was a useless monochrome brick that nobody wanted, to the first iPhone, which everyone wanted and which fit in your pocket, and has evolved incredibly rapidly since then. That took 13 years. And technology is accelerating. And so that Magic Leap headset, when Oculus were working with the Rift, there was the first developer kit, then there was the second developer kit, and then there was the public launch of the Rift. And so we're going to get a second Magic Leap developer kit probably next year or the year after, which will be lighter and smaller and a bigger field of view and higher resolution. And then they'll release a product based on that, and then maybe 10 years down the line, will have managed to shrink that down to something like a pair of sunglasses. And that looks ridiculous, the idea that you could fit everything you need for an augmented reality headset into something like that. And when I made this slide, I thought, that's probably pushing it a little bit. And then I saw this, which is the Nreal augmented reality headset. And that's a real thing that you can actually buy now, and it works. And it's not fantastic, but it works. If you look at it side on, it's got quite a big chunk of technology on the inside of the lens. And this is going to be revolutionary. Once we can actually fit things into something that you don't mind putting on your face and wearing all day, and that you can see through completely, and it can provide additional information and make screens appear. For a start, the entire screen business is going to disappear. Why are you going to put an 85-inch rectangle in the corner of your room, which is there all the time, when you could just put on a pair of glasses and make a 200-inch rectangle appear in front of you and watch things as though they were on the cinema? And this is Leap Motion, the people who made the hand-tracking Mars bar that you plug into your computer. They've actually created an open source augmented reality headset, which you can build yourself with components you can order online. And this is their idea of what that might look like. And so with augmented reality, why would you have a phone when any flat surface I could pick up a mat like this and my augmented reality headset could just go, yep, okay, that's your phone. And I could sort of get two of them together and go, hey, it's a bigger phone. And actually, why does the display part of it need to be restricted to this? The display part of it could grow out to here. This just needs to be the user interface, because it's nice to have something that you're actually touching. We need that tactile feedback. So, yeah. The required skills for this: 3D graphics and modeling, spatial design, and new interaction models. I actually started thinking about this because I was working for a bank, and these guys have insane amounts of data on their screens all at the same time. And they had a skunkworks project that was starting to evaluate using virtual reality or augmented reality to present that data for traders in a three-dimensional space and what that might look like. And so these traders would get rid of those 6 screens that they've got mounted on their desks, and they would just be interacting with data using their hands in a three-dimensional space, but still able to look down and see their keyboard so they can type things in, or their Bloomberg terminal. But yeah, you can imagine a world where we don't have screens and we don't have phones and we don't have advertising hoardings and we don't have an awful lot of the visual stuff that is in the world today can just be digitally produced, which again is going to reduce carbon footprint and materials and everything else. So in order to get ready for this, I started learning Unity, because I'm a .NET developer, and Unity 3D uses C# as its programming language. I'm also building games with my kids. You can actually find videos of my daughter online doing talks at Build Stuff in Malaga, the summer Build Stuff, on what she's doing with Unity. And it's great, because I get to spend quality time with the kids and do the thing I like doing at the same time. Not that I don't like spending quality time with the kids, I get to do 2 things that I like doing. But yes, Unity 3D or Unreal Engine or Godot, or if you want to get on the website of things, if you go to aframe.io, there's the sort of augmented reality, mixed reality web stuff on there. And whilst these headsets are currently really expensive and not really ready for sort of putting on and walking down the street, once they are ready, by the way, for putting on and wearing outside, I already have my first app idea for proper augmented reality. It's an app where, for runners, right, and you go into Google Maps and you draw out the route for your run and you upload it to your headset, and then you go out and start running and coins appear along your route. And as you're running along, you go doing, doing, And then there'll be in-app purchases where you can switch the coins for rings if you're a Sonic fan. And there'll be obstacles, and if you bump into the obstacles, rings will go flying everywhere, and you'll have to run around and pick them all up. Or if you're old, like me, you can have one where you're picking up dots, and there's ghosts chasing you if you look. And the thing is, that's funny, but I'm not kidding. When they make an augmented reality headset that works outside, either I'm making that, or I'm hoping that someone who knows how to make that sort of thing sees one of my talks and goes, I'm making that. And then I'm going to sue them. But probably just for a free copy and free in-app purchases. It would be awesome. But seriously, do cut me in. But at the moment, we can do it on smartphones. You can
Have fun.
already get this on Android and iOS in some regions. This is Minecraft Earth. You can get that now. And you walk around in the real world and you push your phone to mine materials. And then once you've got enough materials, you can go home and you can sit at your table and you can build whatever you want on Minecraft Earth. And then you can put that into your inventory. And then you can go out into the world and just go and plomp it down in the real world. And this is running on Android and iOS, all the current generation phones. And it's also running in the cloud. So when you plonk something down in the world, if you've got a group of friends that you're playing with and you're sharing a world, then they can come along and they can see what you've done. And they can modify it. And they can build things. That girl comes back after her day out, and the two kids, because they're young and young people are better at Minecraft, have taken her little tree and turned it into a castle with dragons and everything. And there are llamas following people around the place. And at the moment, they're doing that with phones. But I think the really interesting and exciting thing there is that that's Minecraft, and Minecraft is owned by Microsoft, who make the HoloLens. And so you sort of think there's a natural point where these two things come together sometime in the very near future. What, 5 years, 10 years? So yeah, this is something real. This is happening, and it's something we need to be on top of. Recommended reading: Snow Crash by Neil Stephenson is absolutely the best book to read about virtual world building and everything. Obviously, there's William Gibson, Neuromancer, and lots of things, but Snow Crash, I think, does a really good job of imagining what this near future might be like. Also, Ready Player One. But Ready Player One works best if you were alive in the 80s and recognize all the pop culture references. Otherwise, it's just a bit of a drag. And don't watch the film. Unless you've already watched it, in which case, I'm sorry. Manufacturing. This is exciting as well. Manufacturing, up until now, has always been... So we've had to program the robots and everything. I'm going to nip through the rest of this because apparently I've only got 5 minutes left and I thought I had longer. No, I don't. I have 5 minutes left. That was all the most exciting stuff. But manufacturing is going to get very interesting. We're not building robots that carve stuff out of raw materials anymore. We're building printers that put the raw materials together to create things. This was the first 3D printer ever. This was in 1992. And this cost $100,000 and was huge. That's like the size of a server rack and could make very, very small things and was not available to the general public. Then in 2007, at the University of Bath, they invented the RepRap version 1. Apart from the dowels and rods and screws, basically those plastic bits on the RepRap, you could print those using a RepRap and then give them to somebody else and they could make another RepRap. It was a self-replicating 3D printer. Now, 12 years later, you can go onto Amazon and search on 3D printer and there's just hundreds of the things. China is churning these things out like you would not believe. You can get a DaVinci Junior, which comes fully assembled, has Wi-Fi. It's just really, really easy to use, costs a couple of €100. I was very surprised because I thought at some point they're going to have, and they've already got full color. So this is the DaVinci Color. This is only €700, and you put white PLA in it and inkjet cartridges, and it colors the PLA as it's printing, and you can print things in full color, which if you've got kids, you'll know is very important. Because if you've got kids and you 3D print Mickey Mouse, but he's all blue, they go, what am I supposed to do with that? And you go, paint it. And they go, what? So now you can print a full color Mickey Mouse. If you've got way too much money, you can get a Form 2, which is a different kind of 3D printing. It uses lasers to cure a resin and gradually lifts a thing out and produces incredibly high resolution prints. And that's really impressive. And looking at that printer that we had 20 years ago, 30 years ago, down to the little printers we've got now, that has progressed quite quickly. And so we're almost at the point where you can 3D print gadgets, where you can just press a button and a fully functioning gadget that just needs a battery adding to it. And at some point, we'll be able to print the battery as well. That's quite exciting. We can print food. This is a 3D printer that's printing meat that doesn't look very nice at this point, but apparently once you cook it, you can eat it without being physically sick, which is amazing. But in terms of the carbon impact of that, it's basically zero. NASA are already 3D printing food, hot pizza and stuff on the space station. In the far future, we're probably not going to get to the point where we can condense energy into matter, but I wouldn't be surprised if we got to the point where we could almost manipulate molecules and put things together. Another Neil Stephenson book, Diamond Age, suggests exactly that. And the reason it's called Diamond Age is because they are putting molecules together to make things. And carbon is a lot more available than silicon. And so diamond is cheaper than glass in a world where you're constructing things from molecules. That is a really interesting book. Also, computers have gone back to being mechanical because they can just build machines like Babbage's calculating engines that fit in the pages of a book. And then there's artificial intelligence, and I'm going to whip through this incredibly quickly. So the history of artificial intelligence: in 1950, Alan Turing proposed the Turing test. I know quite a lot of people today who would fail the Turing test. In 1956, McCarthy and Minsky opened the AI lab at MIT. In 1973, the Lighthill report said that whilst AI was interesting, a computer would never be able to beat even an average human player at chess. In the 1980s, we got into expert systems. I actually did some expert system prologue and that sort of stuff. It was a complete dead end, and we totally wasted the 1980s. In 1997, Deep Blue beat Garry Kasparov at chess, so disproving the Lighthill report. But they said, well, maybe chess, because chess is a finite game. It's NP complete. A computer will never beat a human player at Go, which is a far more complicated game. In 2002, the first robot you can actually buy and put in your house came along. In 2005, Boston Dynamics started making those terrifying dogs. In 2011, IBM Watson played Jeopardy and beat the 3 all-time Jeopardy champions. And it was listening and speech recognition and working out and choosing the questions. It was doing everything. In 2011, Siri appeared on our phones. In 2014, Alexa appeared in our houses. In 2014 also, driverless cars started to run people over. In 2016, Google Assistant started to read you headlines telling you a driverless car had run people over. In 2016, AlphaGo beat a human Go player at Go. In 2017, AlphaZero beat AlphaGo at Go. And AlphaZero hadn't even been taught to play Go. It had just been told, there's a thing, there is a game called Go, and it went, all right, give me 24 hours. And then it beat AlphaGo at Go. The present, breaking news, literally just before this talk I read this, John Carmack is stepping down as the CTO of Oculus to work on AI, and if that doesn't mean AI is going to get better, I don't know what does. We've got neural processing units built into all modern processors and systems on chips. We have got AI as a service, Microsoft Cognitive Services, Google Cloud. We've got SDKs, ML.NET for .NET developers is really worth checking out. OpenCV, TensorFlow. Mycroft is an open source voice assistant thing. There's some URLs there, but they are also on the website. And so in the future, we're going to have quantum computing, which is completely nuts, and I don't understand a damn thing about it. We're going to have nanotech, which is like 3D printing on steroids, and I don't understand a damn thing about any of that either. This talk's designed to be done over an hour, can you tell? If you want to get started with nanotech, by the way, you'll need a bachelor's degree and a master's degree and a PhD and then a research position at a good university. So, this in summary then, in 10 years from now, humanity is going to be wiped out by the asteroid Apophis, which is predicted to pass within 100,000 kilometers of the planet. And I, for one, will be standing at the top of a mountain going, bring it on! Because I fully believe Trump will still be president. If that doesn't happen, then by 2039, there's a reasonable chance we'll have colonized the moon and maybe even Mars, because Elon Musk is awesome. And by 2049, we'll have terraformed Mars, and it will look like this. And we'll start to augment ourselves, because bionics and neural interfaces and everything will have become so good that we'll be looking at people who've lost their limbs tragically in war or in accidents and going, God, I'm jealous, can I have his arms? And we will start to build better versions of ourselves. And I do believe that we do have the potential to create this modern utopia with everything done by 3D printers and clean energy and computers just looking after us and all watched over by machines of loving grace, as it says in the poem. There is a website which has got all the links and all the information from this talk. You just go to futurology4.dev. Follow me on Twitter, Mark Rendle. If you've got software that is stuck in the past and you'd like to bring that into the future, then please check out my new project, visualrecode.com. Yes, this whole thing was just a sales pitch. Thank you very much for listening to me. Enjoy the rest of the conference.